Introduction. We have learned how to find derivative of composite functions, inverse trigonometric functions, implicit functions, exponential functions, and logarithmic functions. In this chapter, we will study applications of the derivative in various disciplines. Example: in engineering, science, social science, and many other fields. For instance, we will learn how the derivative can be used. Number 1. To determine rate of change of quantities. Number 2. To find the equations of tangent and normal to a curve at a point. Number 3. To find turning points on the graph of a function, which in turn will help us to locate points at which largest or smallest value locally of a function occurs. We will also use derivative to find intervals on which a function is increasing or decreasing. Finally, we use the derivative to find appropriate value of certain quantities. Example: sand is pouring from a pipe at the radius of 12 cm cubed per second. The falling sand forms a cone on the ground in such a way that the height of the cone is always 1/6 of the radius of the base. How fast is the height of the sand cone increasing when the height is 4 cm? The solution is, let R be the radius, H be the height, and B be the volume of the sand cone at any time t. Then, B is equal to 1 by 3 pi r square h is equal to 1 by 3 pi 36 h square of h is equal to 12 pi h cube, since r is equal to 6h. dV by dt is equal to 36 pi h square. dH by dt is equal to 1 by 3 pi h square. Since dV by dt is equal to 12 is given, dH by dt of h is equal to 4 is equal to 1 by 3 pi 4 square is equal to 1 by 48 pi. Thus, the height of the sand cone is increasing at the rate of 1 by 48 pi centimeter per second. Example: a man is walking at the rate of 6.5 kilometers per hour towards the foot of a tower 120 meter height. At what rate he is approaching the top of the tower when he is 50 meters away from the tower? Solution is, let any time t the man b is at a distance of x and y meter from the foot and top of the tower respectively, the y square is equal to x square plus 120 square is equation 1. Differentiating with respect to t, we get 2y dy by dx is equal to 2x dx by dt. Therefore, dy by dt is equal to x by y dx by dt. But given that dx by dt is equal to minus 6.5 kilometers per hour, the negative sign is indicating the decreasing of x. Therefore, dV by dt is equal to 6.5x by y in equation 2. Putting x is equal to 50 in equation 1, we get y is equal to square root of 50 square plus 120 square is equal to 130. Putting x equal to 50 and y is equal to 130 in equation 2, we get dy by dt is equal to minus 6.5 into 50 by 130, which is equal to minus 2.5. Thus, the man is approaching the top of the floor at the rate of 2.5 kilometers per hour. Maths